In this video, what I want to do is discuss the high-level architecture of how we're going to write our server. So I threw together just a crude diagram showcasing all the different moving parts of the entire system, both on the server and on the client. And let's walk through going forward and then going back a interaction. Like, let's say I decided to log in, or no, a better example might be I did something that everyone can see, like I played a card, all right? So what happens, where this starts off is user interaction, right? If I play the card, then then that constitutes as a user interaction. I click on this button, this thing. And then that's going to get sent from my subcomponent, such as the card itself, the card component, sent through a callback that is then going to go end up in a container being the components that are responsible for interacting with our stores. Then the containers will then dispatch an action to the dispatcher. So we'll take that intent and wrap it up in an action. That action then goes into a store action handler. Now the store, in some cases, isn't going to interact with the server, such as when we open up a dialog, for example. That doesn't change anything on the server. But for some things, it will dispatch something to the server, such as if I want to play a card, the store itself will say socket.io, hey, I have this action that I want you to handle. And it'll shoot that action right over into socket.io. So now we're in the internet. Now we are out of the client. The action is out of the client. Then it gets sent into what I call the client, but the client on the server is just a class called client that represents every individual connection to the server. And it's just a class that handles things. And the client, the server's representation of a client, is actually going to be a dispatcher itself. So then it will receive the message from socket.io and then dispatch the action to a handler. Now, the interesting thing about the way I'm setting up handlers is that depending on what state the client is in, different handlers may be attached or may not be attached to a particular action. For example, if I join the lobby, my lobby handlers will be instantiated and they will handle interaction with the lobby. But then if I join a game, a new instantiation of a game handler class will be created that will then attach itself to the game actions, and the lobby handlers will be destroyed and they will unattach themselves from the lobby handlers. So it's kind of dynamic as far as what actions the client is going to handle at any time. So then once the action gets dispatched to a handler on the server, it then interacts with the model. So it then says, hey model, this guy wants to play a card. Can he play a card? Do you accept this? And or not, or this user wants to log in, or whatever. It's just written in plain JavaScript. Think of the handler kind of like a controller, more or less. It interacts with the model. It takes an action, and it invokes methods on the models. Now, what happens when the model changes? So basically, the lobby, the overarching application itself, each individual player object, and the game will all have what's called a view. And what happens is when an interaction occurs, the model will perform the interaction on itself, and then it'll generate a new copy of its own view, and then compare its new view to its old view. And then it'll create a diff between the new and the old views. Once it creates the diff, once it's done performing its operations, it then creates a view diff, and that view diff might say something like, okay, the messages array has one new item in it, or the round has gone from null to having all this information, or this player was the czar and now he's not. So the view diff just contains the properties of the view of the thing we're looking at, such as a game or a player or the application or the lobby, and it sends just the changes straight back through this pipeline all the way back into socket.io to all of the clients that are listening to that particular view. So again, you go from callbacks to actions. Actions get sent over socket.io, handled by the client dispatcher, which then sends actions to the handlers. The handlers then modify the view, or modify the client model. Then the model checks to see what changed on its view, sends back the difference all the way back to the client. Then the stores, so it goes into socket.io, the stores will listen to socket.io in a way, and what will happen is they will then take that view diff and merge that view diff into the last view that was received by the server. Then it now has a complete picture of what happened. Then that new view gets sent over reactive extensions to the containers that are subscribed to the observables. Then they set their state with the reactive extensions value, the value that came from that observable, and then set the values on the props of the subcomponents, and then the subcomponents finally render out to the DOM. So this is the entire cycle of an action that results in a change of a view of a model. So it's important to understand some actions won't change a view of a model, such as if you log in, you'll have your user details set just on your user details. So then this diagram will become simpler. But for the majority of the interactions, it's going to look like this. Actions eventually end up in handlers. Handlers modify the model. The model checks to see what changed during the operation. Whatever happened, I added an item to the messages, or I changed this player to be the czar, or whatever. Sends that difference all the way back to all the clients that are subscribed to it. That view gets merged, sent to the containers, sent to the subcomponents, and you get a render. And looks like there's a lot of moving parts, but in reality, this is actually going to be a very simple setup because you can follow each individual step, and you can watch it, how each individual step eventually results in a message being sent back to the client. Now, I want to point out that the way that I'm working with these things that I called views from the server is mostly due to the fact that I don't want to write a million actions, such as a player was added, a player was removed, a player was updated, a message was added, and so on and so on and so on, which would balloon the size of the code base. However, in certain areas, you might want to do that instead, because certain things like a messages array, you might consider just turning that into its own action as opposed to attaching that to a view for performance reasons. However, the code that we're about to write is performant enough, in my opinion, for a game of this particular scale. So we're not particularly worried about the performance aspects. However, there definitely is a performance cost when performing the diff between the previous state of the model and the new state. And the way we fix that is by making sure that our views are relatively compact and don't have a lot of extraneous properties on them. So yeah, the way that I'm going to start this whole thing, the reason why I wanted to do this architecture overview now, is the first thing we're going to write is the diffing algorithm, because that's going to be kind of an annoying piece of code, but we have to write it. And all it's going to do is it's going to be able to produce a diff and then merge a diff into an existing object. So we're going to do that. Then we'll move on to the rest of the server. And with that, we'll see you guys in the next video.